recording. All right, so this question is basically, you've got your real line here and it says z minus 1, so there's 1, and it says z plus 3, so 1, 2, 3, there's minus 3 there. So the one that's on the right hand side, like that's right, that's left out there, we've got the right over the left here when we have that, right? If you have the right over the left, it's the top segment of the circle. So we're sketching the top segment of a circle. I'll just get a bit more room here. So we know that it's going to look something like, there's 1 there and there's your minus 3, and it's going to look something like that. It's the top part of the circle. When we do the sketch, we're going to need to know, where does it go through on the y-axis? That's an important thing. And then sort of draw the circle appropriately. So how are we going to find where it goes through on the y-axis? Well, first of all, we need to find the center of the circle, which is somewhere sort of about there, let's say, right? Now, the center of the circle, I'll just put it there so I've got a bit more room. The center of the circle is going to be symmetrically in the middle. So minus 3, 1, it's going to be directly under there. There's minus 1. So we know the x-coordinate of the center is minus 1. Right? If I was writing the coordinates for the center, it'd be minus 1, comma, and we've got to figure out the y-coordinate. Now we can use that, figure that out by symmetry as well, because we can just say, well, if I look at this here, this triangle here, I know it's going to be a 45, 45, and therefore, since that's 2, that's got to be 2 because it's an isosceles triangle, and then Pythagoras theorem would tell you that's 2 root 2. And so I know the radius of the circle. I also know the center because I go up 2. So the center is minus 1, 2, and the equation will be x plus 1 squared plus y minus 2 squared equals whatever 2 root 2 squared is. X plus 1 squared plus y minus 2 squared equals 8. So that's the equation of the circle of which we're going to sketch that top part. Now, where does it cut through the y-axis? Well, for the y-intercept, you put x equal to 0. So I put x equal to 0, and I'm going to get 1 squared plus y minus 2 squared equals 8. So I'm going to get y minus 2 squared equals 7. So y equals that will be square root of 7 and then plus 2. So whatever the square root of 7 plus 2 is, that's going to be that place there. Now, you might be wondering, how can you be sure that this triangle here is the triangle I said it was? Well, we know that theory with circles, that if you have anywhere out here on the circumference, if that was 45 degrees, then the angle at the center of the circle is going to be twice that. So the angle at the center has to be 90 degrees. And then I just said, well, I'm actually working by symmetry here. So if I take that triangle, that half a triangle, then the top angle in that triangle is going to be 45. So that's where I got that from. So now I can sketch that because I know it goes through the y-axis up here at root 7 plus 2. I know it's out here at minus 3. I know it's here at 1. And I know I go up to 1, minus 1 and 2 for the center. And it kind of goes out. Because it's the it's like a major segment of a circle. Now, so an important point to make here is that you can't get an argument of 0, so you need to actually have open circles at either end there on the axis. So I've got my 2 open circles there at the end of the segment part of the circle, and it's root 7 plus 2 is up there where it goes through the y-axis, and we have our picture, we have our sketch of z minus 1 over z plus 3 equals pi on 4.